So in my previous video, I looked at working memory and essentially the limitation it applies on us in terms of the amount of information we can handle. And I briefly suggested a few different things that we can do to essentially free up space in our working memory so we can make maximum use of it. And one of the things I said would be great to do is put some things in long-term memory. So in this video, I'm going to look at some specific context in physics of things that we want to put in our long-term memory and how we can go about doing that. So the first thing I'm going to look at is what is long-term memory, and then I'm going to look at why it's good to put things there and how we go about storing stuff in our long-term memory. Because like anything else, there is a process to go about doing that. So what is long-term memory? So it's the information you already have in your head that you can retrieve easily. So it's not stuff that you've just put in. So, if I'm reading something, what I'm doing is I'm reading something is I'm taking information, I'm putting it into my working memory and I'm juggling around with it in my head. But what that doesn't mean is that I will be able to know that a week from now or a year from now. So the things that I will be able to recall even in a year or so, that's stuff that's in our long-term memory, and that's what we want to achieve when we're learning stuff. So the way we achieve that is by repeatedly retrieving information from our memory. So that what that isn't is putting the same thing back in repeatedly. It's finding ways of being able to extract that information from our head over time. That's how we make something a long-term memory. Okay, so would we want to do that? And essentially, how do we go about putting stuff in the long-term memory? So, as I said, what we're aiming to do is essentially keep something in it so its retention or the amount of it stays as near as possible 100% over time. And the way we do it is by repeatedly coming back or retrieving it. So you can see that on this graph. So if we just read something, we take it into our working memory. What will happen is over time, the amount we remember about that's going to decay. So you can see by about 3 days, we're at about 60%. So we're already nearly half of it's gone. So this is called the Ebbinghaus forgetting curve, and it's fairly famous in learning psychology. And essentially what our aim is to do is change it so essentially we're retaining that information. So you can see that if we can come back a day later and review it once, we can slow the rate at which it's decaying away, and the more times that we come back to it, the rate at which it decays decreases over time, so eventually it's pretty much stuck in our head. Okay, so that's what we're trying to achieve by doing this retrieval over time. So why do we want to put things in long-term memory? Well, in the previous video, we looked at working memory, and it's essentially the number of items your brain can simultaneously juggle. So if information is stored in your long-term memory, it doesn't take up a slot in working memory, so it frees it up for something else, which is why it's useful. So think of that as these green ones. So if the green ones are in long-term memory, what we've done is we've essentially created additional slots we can work in because that information doesn't take up working memory. That's what we're trying to achieve here. Okay, so how do we go about storing information? So as I said, long-term memories are created by repeated retrieval over time, or in psychology, that's known as testing. But that word scares people, so they've substituted for retrieval. So it's essentially this process of extracting information from your brain. How do we go about doing this? So one thing I recommend you get yourself is a ring binder, because a lot of the strategies that I'm going to show you will fit very well with that. So it's really invaluable. Get yourself one. Okay, simple. So if it's just simple factual information I need to learn, I'm going to split my page into 2 columns and I'm going to fold it. So what I'm creating here is a retrieval practice resource. So what I can do is I can fold it over like this, and then I go, okay, so force is my quantity, and then I go, okay, so what is its unit? And I try and dig into my brain and go, do I actually know this? I do, okay, it's newtons. And what I've done there is I've retrieved it, because I've gone into my head and I've pulled it out. The unit of force is newtons. And I could do this the other way around. I could go, well, what's measured in newtons? Okay, well, it's a force. So I've retrieved it once. So what that will do is that will slow the rate at which that information is decaying in my brain. Okay, and I could do this for all the different quantities here. So you might go, oh, can't I just print out something online that someone's already made? Yes, you can, but this simple act of actually making this will help with your retrieval. Okay, so I would suggest you making this for yourself. And so I've just stuck a load of random quantities there. You might want to do this topic by topic. It really doesn't matter. So this is a very simple thing you can do. This makes a simple retrieval activity. You're just basically testing yourself. Do you know this? Yes or no? Then on the next page, I keep a list of the ones that I'm struggling to retrieve. So I've got gravitational field strength. Oh no, I don't know what this, and I've had to look. So I've collected a list for myself of the ones I'm finding it difficult. So I've tried several times, but I'm still not remembering those. Okay. So then that gives you something to focus on. So going, okay, I've recalled force loads of times. I don't need to focus on that right now. I need to focus on this difficult units one. So that's one thing we can do to help with the more challenging ones. Okay. Thing we can think about doing this for is equations, because as I said, it's really good to have equations in our long-term memory. So having a sheet which split in half with the what we're calculating and the equation to calculate it, again, really useful. Even if it's given to you in exams, we want to have these in our long-term memory. Okay, and again, what I'd have is, okay, so I'm struggling to remember these two equations. I've got them on a difficult equations list. So that can be useful to us to have that one. What if we're struggling to store something? So what are some techniques we can use if we got, okay, so I keep testing myself, but I'm just not getting it. I just don't remember what this equation is. So there are two techniques for helping with that. So one is elaboration. So adding more information into the equation. So here we've got an equation of potential difference, which is W over Q. So we're going, okay, some elaboration might be, okay, so what do all these things actually stand for? What extra information can we add on to this to make it a stronger memory? So we go, okay, so this is potential difference is the work done per coulomb of charge. So this is what this equation is actually meaning. That might be one thing that helps. The other thing we can do is use silly phrases to help us remember this. And I used to do this a lot. I can still remember a lot of the ones I came up with. So like, I remember I had very Irish rat for V equals IR. I had elephant's question velocity for this very equation here. So energy is charge times central difference. So for this particular equation, the one I might use is voles worry over the queen. Now, you might ask yourself, well, why are voles worrying over the queen? Well, that doesn't matter. It's just silly and a bit nonsensical. So here we go. So this would be mine that I would use. So this is a cue to help us remember this equation. So voles tells us it's V, worry tells us it's W, over tells us it's divide, and queen tells us Q. So voles worry over the queen. And it's bit more memorable because it's silly, it's a bit stupid, it uses animals. So that's how I might go about remembering that equation if I'm struggling to remember it. Okay. So again, we can use this with forces. So with the same ones, we might elaborate. So we go, okay, so what does this symbol actually mean? So we're adding some extra information in there. We're actually really thinking about this equation. We can also come up with a stupid rhyme for this. So foxes won't cross mad anacondas. So you want to foxes gives you force, cross gives you multiply, mad gives you mass, anacondas gives you acceleration. So you'll see in mine I use animals a lot because I really like animals. So it really associates well with me. If you're really into football, use football things. If you're really into music, use music things. Use whatever you like that gets it stuck in your head. Often rude ones work the best. No one really knows why. Using swear words, using dirty things, whatever you like, often helps you remember it. As long as you're not saying it in appropriate context, who cares what you use to make it memorable? So let's reflect on what I'm trying to achieve here. So at the video, what the things I'm looking for is what is a long-term memory? Why is it good things to put there? So thinking about working memory and its advantages for that. And how do we go about storing information? So we're talking about repeated retrieval over time and giving yourselves ways to help that retrieval process work a bit more effectively. That's what we're trying to get out of this video.